Very good afternoon, everyone. It's really amazing to see such a good audience here after a late afternoon. I hope everyone is feeling fresh because I can assure you that this panel is going to bring some of the most insightful sharing in terms of how we can bridge the gap between the factory deployment, between the technology that we see in the market, and bringing them from pilots to actual deployments. Right. So my name is Edwin Yap. I'm the founder of Kinisi Robotics, and I'm pleased to be moderating today's discussion. We have a great panel with us today. We have Sviat Dulianinov from Bright Machines, Yves Albers-Schoenberg from Roboto AI, Brennand Pierce from Kinisi Robotics, and Vincent Despatin from Kickmaker. So the topic today is very practical, right? Robotics and physical AI are advancing very quickly. But the real challenge is no longer how do we make something that's impressive. We're looking at the harder question, which is bringing the technology from real, just demo into real factories and making them reliable, integrating them into existing workflow, proving the ROI, and scaling beyond the pilots. So to start, I'll ask each of the panelists to introduce themselves and also tell us about what is the biggest gap that they see right now in the market between pilot and real factory deployment. So if you can just start with Sviat by introducing yourself, please.
Thank you. It's great to be here. Thanks, Edwin, for moderating. So my name is Sviat. I'm the CEO of Bright Machines. Maybe quickly, what we do at Bright Machines, we are building the factories with a new approach with robotics and AI first, and we run those factories to assemble complex electronics. We focus 100% on what we call data center infrastructure, so you can think about compute. All the servers and racks that go to data centers, we assemble them with robots powered by AI-enabled software and data. And just to understand how we operate in this, like this segment of the market operates, I think the big gap to the point of the panel is the operations ownership. As you might know, in electronics, there are like designers of the product that are OEMs, and there are like manufacturers that are usually called CMs, contract manufacturers. And historically, most of the manufacturing has been centered in China and designed somewhere in California, like if you think about Apple. And then, some other companies trying to provide solutions like robots and software to deploy on those floors. And because of that triangle, actually, it's kind of a bottleneck to fast deployments and evolvement of robotics in the industry. And we can deep dive into this later.
Okay, thank you. Yves, please.
Yes, hello everyone. Super excited to be here. My name is Yves. I'm the CTO and co-founder of Roboto AI. And we're building a data analytics platform for robotics data. So if you're collecting a lot of data, in the manufacturing context, drones, self-driving cars, you need to analyze all of that data. You need to be able to search through it, you curate it, and then we're building a SaaS platform to help with that. And maybe some of the biggest gaps that we're currently seeing, I think we see a lot of pilots that are failing because ultimately they don't really achieve the uptime and reliability that are required for to operate at scale. And we see a big part of that is kind of that there's not enough data available. And I think in two respects. On the one side, there's not enough data to really train these models for like these specific applications and make sure they're reliable. But there's also not enough operational data to really prove to the executive sponsors that the system is ready for scaling up. So really kind of more data, but the right data. I think that's a big bottleneck right now in the whole industry.
Right, very interesting. I think definitely we've been seeing a lot of mention about data, whether in every panel or even sharing by most of the keynotes that we see today. Brennand, please.
Hello, nice to meet you. So I'm here for CEO of Kinisi, but also founded multiple other robot companies. I can say historically, if you stick with the AMR robots, they're basically out there. My previous companies shipped tens of thousands of them, so it's pretty easy. I think if we take this more on the future, humanoid-esque AI, I think we'll get into a better discussion about how hard it is to bring hardware into the real world. I could just say, not only software, but generally it's a scaling problem. If you're just a pure software SaaS company, you can go out and start 100, 500 pilots to really figure out who wants your product. When a robot costs 50,000 per robot, you can only go and do like 20 pilots realistically, and you just got to pray, and your whole startup is based on, will one of those companies want that robot? And then the other aspects is, you keep on wanting to update the hardware, and now you got, like in Kinisi, my company, like 10 robots into the field. Now you have to keep on trying to update them. They all get out of sync. They're all different generations. And yeah, this is the hard part about the valley of death before you go into mass production.
Right, Brennand is definitely the veteran of robotic startups. Also read about your recent exit to Bear Robotics. Maybe you can share a bit about that later as well.
Oh, what's that? Sorry, was. Oh, yeah. So
Yeah.
I sold my company 2 weeks ago to my previous company. I like to say, do it, Elon Musk. And generally, that is. It shows how hard, even as a, I don't want to brag, but I've done multiple robot startups, and you show it's really quite hard to get out there, raise money, and actually scale. So it was a quite natural fit to sell it to my previous company. They already have like 150 salespeople. They have factories set up in Asia. They have all the infrastructure we needed to scale that we would have had to try and compete ourselves. And at the moment, there's about 200 other startups basically trying to do the same things. It's quite hard to stand out.
All right, thank you. Vincent?
Yes, I'm Vincent Despatin. I'm very happy to be here as well. 10 years ago, we started Kickmaker here, actually in Station F. We were one of the first startups incubated here. 10 years later, 300 engineers based in Paris, building robots, industrializing robots for third party. So I'm very happy to be sitting next to a previous customer, and I can see some other customer in the room here. So to us, industrialization of hardware is definitely the key right now. When we speak about the gap between indeed prototype and factory, industrialization is a huge step. That's the valley of death. And before that, indeed, what Brent was saying, design freeze of version is very important. But as the Moore curve is accelerating, people are actually, developing product faster and more, and you want more feature because you want to have the latest technology inside, and that kills everything. So to us, the biggest challenge is how to read the future. Nothing will be basically customer ready within the next year or so, 18 months eventually, but still you will have to deliver something to customer that works and works at scale. And in the meantime, we know that electronics is an industry that is fairly outsourced. So that means that you need to manage dependencies with CM, with third party, with tech providers, and thus managing all that is very hard.
Yeah, very interesting perspective of managing different stakeholders, especially when different industries typically have different setup in terms of the structure of their teams. So the next question I'm going to actually come back to Sviat. So Bright Machine talks about intelligent manufacturing, right? So how different is it, comparing intelligent manufacturing to conventional, traditional manufacturing? Is it just as simple as adding an AI element, or do you have other thoughts?
Not really, but maybe yes. One step back historically. As rightfully mentioned, manufacturing depended a lot on contract manufacturers, mostly, by the way, around Asia. China first, and then for some components in Taiwan, and recently in Philippines and Thailand. But the problem is the way they solve the problem when they get some inputs from OEMs or designers is like to put people first and try to solve it with the flexibility of humans. In China, if you go to Shenzhen, there are like factories that employ 100,000 people on a given day for those reasons. The way we approach it is from different angle. First, we start with design. One of the biggest problems is connecting design and manufacturing in advance before you start production, because then you can optimize for robotics and automation. Then we use robotics and software for manufacturing. Then we use software to collect the data that can drive further efficiencies and can improve your next generation designs, because you already know from your line how it was built, where the failures came from. It could be better supply chain and better components, or it could be different end-of-arm tools, could be different sequence of operations, and so on and so forth. But the way we look at our approach that we call a Bright Factory, we put robotics and software first, also AI-powered design, and when you put all this together and then use this data in the future for future improvements, that's how you drive a different approach to manufacturing versus what existed for 50 plus years around China and Asian regions.
Right, it's great that you mentioned about data, and especially that brings me to the next question to Yves specifically. So you mentioned that one of the biggest gaps you see today is with data. So what do you think is missing today in terms of the infrastructure among trying to build a robotics data and filling that gap of bridging between the vision to what we are now? Yeah.
I think what we're seeing is like kind of an interesting thing. Is like we call it like the data paradox in robotics, where on the one side you have too much robotics data. So we see companies scaling up, they have bigger fleets, more manufacturing robot, they generate a ton of data. The data is multimodal, can be point clouds, image data, time series data. You can amass terabytes just in a couple of minutes. And these companies actually just don't have the tools to automate the inspection of that data. And what's happening is that a lot of edge cases are slipping through, and they end up hitting, customers. So that's kind of one part of the data problem. And then the other part of the data problem, that's what we're hearing a lot today about, is that there's not enough like high quality data to train these models and kind of build, generalizable models. And what we think kind of, to solve both of these issues, you need better data infrastructure that really helps you to search through all of that data, structure the data, and find kind of the events and patterns in all these data sets, which are actually going to make a difference. So it's really like, you need a data analytics engine to deal with the sheer size of this robotics data. And that's a lesson that we've also learned from the AV community as well.
Right, data paradox is definitely a very interesting term that we hear today, because a lot of people have been talking about data collection. So not many are actually talking about the engine that powers how to collect the data, annotate the data, and making the data actually useful for all the AI models, right? So the next question I have for Brennand is, after having so many exits and getting closer to Elon Musk in terms of net worth, definitely more than any of us here today. So how do you decide which factory or warehouse tasks are more suitable for automation?
That's a great question. So at the moment, we're like inundated with inbound from customers that say, we need humanoids. I think this is like the cryptocurrency, or let's say it's the blockchain of like a couple of years ago. So the CEOs are like, we need humanoids in our factory and warehouse. So we get like inundated. We normally have like this gating factor where we chat to them, they send us videos, we can actually tell them if it's realistic, if it's not, how serious they are, what other aspects that goes into it before you decide to take on these customers. At the moment, very boring, repetitive tasks, and try to like cluster them so you can solve one customer's problem and sell it to a lot of others. For us, it's just like driving around, picking up totes, doing assembly lines. I do think with the data paradox, I think it's quite amusing. Historically, you couldn't do a lot of these tasks because you would need a lot of engineers to hand code all the tasks. But we're finding at the moment, most of the time, with the amount of data you need to collect, you could probably actually just hand code a lot of these tasks with just classical controllers. So it's a chicken and the egg problem. It's as well as we're chatting about how to ramp up, it's also, you need like hundreds and hundreds of hours of like training data sets, and if it goes out to distribution, it doesn't work. How to get it to 100% is still like a very hard task, I think, to actually see these as real robots doing real tasks. We semi-cheat now, so not only do you collect the data and get your models to about 95%, then you need to then use Claude and hand code monitoring systems using classical controllers, using like YOLO, SAM, and things like that to be like, all right, if this scenario happens, reset it and do all these things that you have to basically hand tune it to actually work and deploy these foundational models at a customer site, which goes back to the fact that you could have just done this with classical controllers for a lot of these tasks, but that's obviously a dead end, and why we're trying to get better at getting foundational models to run. And I think the last point as well, why you haven't seen this, is customers want these robots to work fast, efficient at 100%. We just finished what we thought was a successful pilot with a customer, but we're about half the speed of a human. And our robots are half the cost of a human, so it sort of works out. But they're very happy. Like, we actually have a robot working 100%, can do a shift for 8 hours. All our engineers like, this is bleeding edge technology, and you see the CEO and the executives just looking like, so when's it going to get faster?
Right, but definitely the idea is, you're starting at 50% now, but there is a potential for you to get to 60, 70, or even closer, or even surpassing the speed of a human speed, right?
Correct.
Right. So that brings me to the next question. When we are at that, utopian world where all the boring and repetitive tasks are being done by robots, right? That means scaling the robots from, I think last year the humanoid robots production was close to about 15,000 units. So let's say we get to that vision of millions of robots being produced. How do you think that people are not really noticing right now, from getting from right now to that utopian that we're talking about?
So first of all, the question, and just answering to Brennand, are these factories really needs humanoids at the end of the day? Most of these repetitive tasks at the end of the day don't need what we call a generalist platform, okay, general purpose robotics. They just need a task to be done. And in general, I think this is where we confuse most of the thing. The robot is not the product. The system is the product. The solution is the product. And within the product, basically 30% is the hardware, but 70% is about integration, it's about data management, maintenance, and servicing the end customer. And all that basically is not ready. It's not ready, why? Because the traditional system integrator for robotics are working with very fixed environment, very repetitive and reliable task. It's not in a real world environment where it comes to smart data, smart management, physical AI, we want everything to be seamless for everybody. So to me, there is a huge gap between where we are today and what the market needs in terms of pure automation. And when we look what's happening in China, 50 hardware companies are going IPO this year. They fight for it. 50 at once going IPO. So I think that would be a huge market consolidation. Thanks to China, we have a supply chain that's here working with reliable components. But at the end of the day, the customer end specification isn't ready. So I think it's time for all of us basically to learn. And the first thing to learn, as Brennand said, is how to run POC, how to run pilot phases with customer success, how to service customer well in that kind of environment, how to engage discussion with the CEO where it does not expect you to deliver the throughput, but just understand that you will help him learn basically how to use technology in the same way that he's just learning how to use cloud, because cloud in 2 years from now is going to be completely different. So at the time being is like, how do we make this entire economy sustaining enough with well-managed funds so that we just don't do all the same and we just come with a professional offer at once the market is ready, and when we until then, only then, sorry, we can start to fight with union that we're going to replace workers.
Right, definitely the acceptance of, I think, Brennand, you have something.
I was going to say, when you said, how do you gate your customers, what Vincent was saying is, if a customer says, what is your picks per hour, you know it's not a customer that's going to be happy with humanoid at the current rate.
Yeah, because earlier we also talked about stakeholders management, right? So the people who audit the humanoid are often not the users of the humanoids, right? They're not replacing the tasks that are being done by that person, that particular person. So a lot of this really comes down to the acceptance level of the society in terms of, do we really want to get them to replace us so that we do nothing? And there's definitely a lot of discussion that revolving around how do we make people accept automation, accept robotics even more. So I think it's interesting that you mentioned about the supply chain from China. And do you think that there is a possibility for them to converge in terms of supply chain, just like how it happened with EV cars, just like how it happened with mobile phones, where there are only a few screen makers now, there are only a few microphone makers and battery makers and so on?
At the end of the day, everything comes from the customer request, okay? So if you go to China and you go AGBot, basically, you know what they are doing right now? They are throwing this little Wukong robot in every house because it's a robot for children. And these guys, basically, in 5-10 years, they will very welcome robots because they will have been playing with it for a while, right? And the supply chain at the end will follow. At the time being, we are seeing like a work that is in two parts, China on one side, US on the other side, but we all know it's not true because there is a lot of money and technology flowing from one to the other. And what are we doing in Europe? Okay, when will we get our first GPU ready? When will we get ST, bringing a platform that is able to compete against NVIDIA? We are having in France, and just recently, our first EV car factory for batteries, so that's good, and so on and so on. So it's very difficult to say if everything will converge, but I do think that at the end of the day, once every people from its personal use will start to welcome automation, everything will follow.
All right, definitely can't wait for that day to come. So the next question brings me back to Sviat. So Bright Machine is focused on building the infrastructure that powers AI, including data centers and AI hardware. So how are this AI infrastructure boom that we're seeing around that is actually changing the urgency and the scale and even the complexity of this game now?
Actually, in a really positive way. So we are 8 years old now, and we started as a company. We built all different types of electronics, from like smoke detectors to drills to coffee machines like Nespresso. But when you build units that are like $90 or $80 per unit, and everybody cares about units per hour and like not that much yield because it's like a cheap units, the motivation to invest in innovation and explore new methods was not as high. Around 4 years ago, we made the bet on data centers, 4.5 maybe, and then a little bit less than 4 years ago, ChatGPT moment happened, and maybe half a year afterwards, every market in the world started looking at how we build AI infrastructure to support needs for AI development and the models. And then they realized that each server compute node that we build can go up to like $350,000 of components in it. The cost of mistake is really high. If you break a GPU or like a motherboard, if you break a GPU, it's like 30K. If you break a motherboard, it's like, 10, 15K. And then the tension is higher, and the desire for automation and actually excluding people from the process loop is really high. And so right now we see a lot of interest in that, and that's why we work with like leading companies that build out AI infrastructure and build a lot of servers and racks for them, with robots first and humans second. By the way, just maybe quickly to follow up on the idea of like creating jobs versus taking robots and reducing the jobs. Our model is pretty cool because we take robots, but we still create jobs because, as I mentioned, the complexity of the design is still so far from 100% automation. You still need humans in the loop, both for assembly, but also engineers for like services and other things. So actually, that makes the whole use case of deploying automation in the markets where you don't have enough labor in terms of skill and also like the scale of that labor. Like you take Germany, the US, UK, I know France, maybe it's actually a really good use case. And that would resonate with both workers and the companies who want to put innovation into operations.
All right, very interesting that they're actually putting more people, human in the loop, and basically training people so that we can unlock our hands in the future. And the next question is for Yves. A lot of companies talk about data flywheels, right? Starting early so you get more data to improve the model, and from then you deploy more robots that gets you even more data. So what does a real data flywheel look like in production, not just in a pitch deck?
Yeah, I think it's a very good question. I think what we see in reality is that kind of like most companies don't really have a data flywheel. They have an issue in operations. They have to kind of manually pull these log files, analyze them, visualize them. And so I think what a real data flywheel looks like, you want to kind of automate as much as possible of the whole analytics process of your data pipeline. And so that starts with automatically getting the data off your vehicle or your production lines, being smart about what data you get from your production lines. Then you want to index your data, you want to make it searchable and enrich it so you can start to run queries against your data. And then on top of it, you want to have like automated ways to triage your data sets. So like if something goes wrong, why did it go wrong? Who should look at it? Should the perception team look at it? Should the navigation team look at it? Where you start to kind of automate a lot of that analysis. And I think that's kind of where you're getting to really kind of a true data flywheel, which is a bit different than kind of the classic training data flywheel. More robots, more data equals better models, more robots, which is good for pitch decks, but I think in reality it's more nuanced than that.
Right. So do you see like a trend of actually having and seeing more data engineers in factories right now because of this shift?
Yeah, and I think in general, I think what the industry kind of needs is maybe not so much more models or better hardware. It's more like I think something like a DevOps process for integration. And so it's not just a one-off integration. Okay, you have all your integrators, they go there, they do the pilot, and then hand it off. It's more like you need to have like site reliability engineers, forward deployed, really kind of tuning these models, making sure we get the right data. I think that's kind of where the industry has the biggest bottleneck right now. And I think we could see way more actually applications deployed with today's hardware and technology if we have more of that kind of DevOps culture in robotics as well.
Right. Speaking of hardware, I think Brennand would be in the best position to answer this question. So what do you think is the danger of over-designing robots for science fiction, looking exactly like a human, instead of actually building something that solves the pain point of the customers?
Money. So the problem in robotics is it's competing with China. It goes all the time. At Bear Robotics, we shipped like 15, 20, maybe even 25,000 robots now. But we're probably still like 20% more expensive than Pudu, and we build them in the same factories. It's just unfortunately with China, they have an unfair advantage, or their government subsidize them. And then the big problem is CFOs, they will look at the cost, and it all comes down to that. They'll just be like, no matter how sexy your pilot is, they will look at two things. What does it cost currently? What does it cost for your competitors? So at Bear, you even start chatting about, can you afford to put LEDs in it? Because when you're shipping that many, you're just like, well, you put an LED, the size of the screen, it's $50 here, $50 there. You're suddenly like, you do that over 10,000 a year. You're like, that's $500,000. That's $500,000 profit margin. Or if you're robotics, you're lucky to have a profit margin. And then I think realistically, it's getting to the point where hardware and the robots is now a sunk cost, and you never make money in robotics. You have to look at making your money back on the WMS layer, on the warehouse, on the OS layer, or some other way where you're just like, here's the robots, we're going to lose a bit of money on it, but if we deploy like 20 to 100 to 200 in your factory, we'll also do X, Y, and Z, and you make the money there, because it's such a cutthroat industry, and it's just quite hard to compete in pure robot world.
It's most likely going to sort of like evolve into how we're getting our cell phones now, right? So basically the phones are free, you're just paying for subscription.
Exactly.
It's going to be the same case as robotics as well.
I think it's also like the same as any electronics, it's like a cutthroat industry. Look at washing machines and things like that, where there's not many players because there's not many profit margins in there. Anything else, you get to like a 5% profit margin. And for a dishwasher, you don't need a room of 100 AI engineers that are competing with Google or something for salary and all the rest of the engineers for the cost factor that goes into it.
Right, okay, thanks so much for sharing. So Vincent, what separates a good prototype, as we're talking about manufacturing, right? What separates a good prototype from something that's truly ready for manufacturing?
So I think it all comes to a very specific question. Engineering team will say a prototype, yes, that's work. But something that is scalable and manufacturable needs to be done 1,000 times by someone that has not designed it, okay? And to come to that stage, basically, that means, first of all, we need to make sure that it's the end targeting operator that is assembling the robot himself to understand if your design is reliable, okay? A good prototype will be something that helps you raise money, okay? A good workable product will help you basically make money out of the blue. And that's the entire difference. And to come to one point to the other, it's really a transition phase stage matter, okay? And the biggest mistake that we have seen so many times in so many companies is using your R&D engineer to do this industrialization, okay? And the main point, again, coming to China is that we have outsourced so much of our design and innovation to China that we have very, very few engineers that know basically how to industrialize a product, make it predictable, and also just, let's say, handle the pace of industrialization, okay? Because plastic needs time to freeze. You need time for long lead time components and everything. And this is definitely not the same team to be able to handle everything, okay? So cadencing, planning, everything is key, basically, to come to a good working prototype and something that is manufacturable.
All right, thank you so much for sharing. So this, the next question is going to be a little bit cross-panel, and I like any panelists to jump in as you like. So do you think manufacturers are focused just too much on the ROI, just too much on the costing, and they're ignoring some important factors such as quality, reliability, or even safety?
Yeah, I mean, we are not here, and I know that the next panel is going to be about cybersecurity and safety, and that's going to be a very interesting point, because this is something that we have seen from customer requests just very frequently, because a year ago, everybody was about like, okay, I want a robot, whatever is inside, I don't care, okay? And I will go CE marking, whatever certification that is there, because people will sell pilot. But now people are starting to be serious about it, and they want a robot that's safe, okay? But at the time being, we have safe component, okay? We don't have safe system, okay? This entire question is very important. I do think that supply chain, process, factories, components are there, okay? But how to execute well the process to reach your market is not there, just because we don't know where the market is.
I'll also add, because I've done multiple startups in the robotic space, I think a classic thing that I've done myself before is you get a robot, you're happy with it, and then you suddenly go to mass manufacturing or go to big clients, and they're saying like, have you got all these ISO standards? Have you got all this other certification? You're like, no, I wrote it in ROS with Python, and I got a cheap Chinese LiDAR, and then all of these things. Then we worked with Vincent and Kickmaker before at Bear when we were productionizing. Unfortunately, you're like, I got this really good LiDAR. We've been using it for about 2 years and it works. Then you suddenly go, it's not acceptable. You now need to buy a sick LiDAR that's 4 times the cost, and you need all these certifications. And now you also need an MCU and all these other things that when you get a load of PhD or clever engineers to build the system, that they suddenly forget that there's this whole engineering a paradigm of safety certification. How can you prove its safety? It's even down to brakes on the robot and all these other things that you generally forget about when you're trying to do a startup and get something shipped.
Right, definitely. So as I try to wrap up this session, I'd like the panelists to actually give your opinion on what is that one myth about factory robotics deployment that you would like to correct, starting from Sviat.
I know. I think the main myth is like most of the videos that you look at, and they say like this is the deployment is mostly in the labs, and when you get to the real production, it's much more complex and complicated. But to be fair, I think like this general purpose stuff is like maybe nascent. The other camp that we're part of, like use case based applications, is more advanced, and we can see actually finally how much faster and more flexible we became in the recent years. moving away from the lab to real production and being able to produce, hundreds of thousands of units from those robots per year with yield and throughput. But again, when I see many of the videos, it's a little bit funny because I know that most of them are lab environment. And hopefully we're going to get to real production really soon with that technology, but it's going to take years.
We're starting to see some now. All right, Yves?
Yeah, and I think maybe building on top of that, I think one myth that we're hearing a lot is just get more data and it will solve all the problems. And I think, sometimes I get emails, I'm selling you 500 hours of robotics data, you want to buy it, I have no idea where it comes from. And I think what we see is, yes, more data can help, but you need to be very strict about quality and where it comes from, and that can really move the needle. And too much data is also a problem as well. So yeah.
Yeah, as I was just talking to one of the exhibitors outside, so I was asking them how is it, and then he just told me like more than 10 people have come up to me and say they want to send me data.
Just today, some people approach me, do you want to buy some data? And I'm like, what data?
There's a lot of people that are like, we'll collect your data, and like, I don't know what data we need. Great answer them. I would just say, the one thing that surprised me over the last couple of years is, we talk about humanoid, AI in this. I've gone to big companies that have like 500 factories or warehouses, and you walk around and you don't see one robot. You just see hundreds and hundreds of people. So you don't even need to get the cool AI or the humanoid robotics. You look at it and be like, have you ever heard of something called an AMR? You know what I mean? It's like you could buy 300 AMRs and instantly get ROI. And they decided to skip all of that and then talk to a humanoid company, which always makes me chuckle.
Last but not least, Vincent?
All right, I will conclude with a sentence proposed by our best friend Claude. And to conclude that panel, basically say, physical AI is the headline, but deployment will be the story. So,
Word.
I should have done that.
Definitely good. All right, and with that, I'd like to wrap up the panel. Thank you so much for your time today.